Hi, everyone. One of the asymptotic properties of the OLS estimator is that it is consistent. And in practice, you will prefer to say something like this instead of saying that the OLS estimator is unbiased. And this is because unbiasedness requires two strong assumptions about the distribution of the error terms. So let's instead work with the consistency property, because that's what you will most likely say in practice. And we basically say that the OLS estimator is consistent if the probability limit of your estimate is equal to the true value of the parameter beta. But what is the probability limit? Probability limit is the convergence in probability, or uses the convergence in probability. Convergence in probability tells you that, and we are using similar notation, okay? So it tells you that the limit when n goes to infinity of the probability that you make a mistake when you estimate your beta is 0. Now, how do we measure this mistake, or how do we refer to the particular mistake? Well, basically what we are saying is that the difference between your estimate and the true value being greater than a small number is what we are referring to as making a mistake. No? And basically, the whole expression is telling you, okay, so the probability that you make a mistake is 0. And that's it. That's all the intuition that you need to understand behind this expression. The other important part related to the consistency of your OLS estimator is that the probability limit for the univariate case, no, of your beta hat is what we found before, the covariance between the dependent variable and the independent variable divided by the variance of the independent variable. And I consider these are like the minimum things that you need to remember, especially in terms of intuition related to convergence in probability, which we use when we talk about the asymptotic properties of the OLS estimator, saying that it is consistent. All right, so that's it for this video, and see you next time. Peace.